Hi, welcome to Kalaimari's tutorial. In this session, today we'll see about polymorphism in C++. Polymorphism is the ability of an object to perform differently in different instances of time. So let us example for that. See, suppose we are taking a person as an object. He will be acting like a student in the classroom, and he or she will be daughter, son, or he'll be the brother, sister at home. The person is the same, but his role is getting changed depending upon the situation. So this type of ability to an object to take more than one form is called polymorphism. So it can be implemented in two ways. One is compile time polymorphism and another one is runtime polymorphism. So we can implement compile time polymorphism by function overloading and operator overloading, and runtime polymorphism with the help of virtual function. So we shall see about these things one by one. So this is the picture showing the categorization of implementing the polymorphism. So now let us see about compile time polymorphism. So we can implement, as I told earlier, we can implement the compile time polymorphism in terms of function overloading and operator overloading. So in function overloading, the function name will be the same in both the classes. But how the appropriate function is going to be called is based upon number of arguments passed and type of arguments passed to that particular function. If suppose I am having the function named add, to that if I am passing only two arguments like int a comma int b. So through the object, if I am passing only two values to this function, so immediately the control will be passed to the function which is holding the two arguments in it. So this is one example of calling the appropriate function with the help of the number of arguments and type of argument. And next is operator overloading. So here the operator will be the same. So it will be acting differently in different instances. Suppose I am taking plus as an operator. If I am passing numeric values to it or integer value to it, it is going to perform the addition operation. If at all, if I am going to send string value as an input, again it will be performing the concatenation operation. The operator is the same, but the functionality is going to get varied. So all these things is going to occur during the compile time. So the compiler itself, it will be able to select the appropriate function for a particular function call at the compile time itself. So it is called as early binding, static binding or static linking. And this we call it to be compile time polymorphism. So now let us see runtime polymorphism. See here in both the classes, we got two functions with the same name, but we haven't passed any arguments into it. So in this case, what happens? The compiler will not be in a position to find to which function, appropriate function, the call has to be sent and it has to be executed for its completion of the program. So in this means we'll be using the virtual function and we'll be telling to which function to be called during the runtime of the execution of the program. So this we call it to be runtime polymorphism. So this will be accomplished with the help of the virtual function. Virtual function, already I have posted a video. If you want, you can go and check that video. I'll give the link in the description. So here in runtime polymorphism, the prototype of the function should be same in both the classes. But the function is not overloaded and therefore static binding is not possible. So for getting the function overloaded, we have to pass some arguments into it, right? It has to be overwritten. So based upon number of arguments passed to it, the compiler is going to find which function it is going to call and perform its execution. So that is not possible over here. So this appropriate member function is going to be called during the runtime. So this we call it to be runtime polymorphism, and this is going to be accomplished with the help of the virtual functions. So since the function is linked with a particular class much later after the compilation, we call this type of polymorphism as late binding, dynamic binding,